What's up, my pre-calc people? I'm Michael Princhak, and in this video, we're going to look at the answer key to this section of the AP Precalculus Prerequisite Skills worksheet that covers exponential functions. Just a little intro over exponential functions and how they can be used in real-world solutions. So let's take a look at that answer key right now. And if you want to access this document so you can practice these questions on your own beforehand, head on over to ultimatereviewpacket.com with the link in the description below, and you'll have access to it all. All right, hopefully you know a little bit about exponentially functions. We're going to do a huge unit on it here in AP Precalculus, but right now we should be able to do some basic problems like these. A certain bacteria sample contains 250 bacteria and grows by 30% every hour if left untreated. Create an equation that models the amount of bacteria after T hours. Well, you should remember this basic equation. The amount of something is the initial amount times 1 plus your rate, if you're growing, raised to the time. Pretty basic equation here for exponential. So this first value right here is your initial amount. This is 1 plus your rate if you're growing. It's 1 minus your rate if you're decaying. And then your time is your exponent. So substituting that in here, the amount of bacteria is going to be the initial amount of 250, 1 plus our rate of 0.30, raised to the t, which is in hours. So we have 250 times 1.30, obviously you can add that together pretty quickly, raised to t. So that's an equation where you type in, or you enter in the number of hours t, and you'll get how much bacteria is left after that amount of hours. So next question wants us to figure out how much bacteria is left after 5 hours, and then also 8.5 hours. So to do this, we're just simply going to have to plug in 5 hours. It's really that simple. So 250 times 1.30 raised to the fifth, grab your calculator, and you get 928.233 bacteria. Well, obviously you can't have it a fraction amount, so we'll just round that to roughly 928 bacteria after 5 hours. Then we want to do the exact same thing, but this time we're going to plug in 8.5. So 250 times 1.30 raised to the 8.5 equals, and again, grab your calculator. It's 2,325.19. So again, we're going to round that to the nearest whole number. 2,325 bacteria after roughly 8.5 hours. Pretty simple. All right, the last question here says, write an equation that models this scenario, but where t is measured in minutes. For a lot of kids, converting like this can be a little bit tricky. So what we want to do is we want to be able to plug in amount of minutes. Now, the original equation that we use right here is the t is measured in hours. So what would you have to do to minutes to convert to hours? Because if we're going to use that equation, eventually that exponent has to be hours. But if we enter in minutes, how do we convert that to hours? Well, I always think basic, right? If you have 60 minutes, you would divide by 60 to get, oh, that's 1 hour. So to convert minutes to hours, you simply divide by 60, right? If you have 120 minutes, divide by 60, that's 2 hours. So what we're going to do here is we're going to take the equation 250 times 1.30, but we're going to raise it to t divided by 60. Now when we plug in a time that's measured in minutes, we would divide it by 60, converting it to hours. Then the equation is going to work exactly like how it's supposed to work, where that exponent is supposed to be in hours. So this exponent right here is in hours. Once we plug in t minutes, the dividing by 60 is what converts it to hours. That allows it to work just like we used in the previous example. All right, here it says a population of a city has 25,500 people is decreasing by 4% each year. Key here, it's decreasing. So once again, we're going to use that equation that the amount is going to be the initial amount. Now, because I'm decreasing, it's 1 minus the rate raised to the time. So here the initial amount is 25,500 people. 1 minus the rate of 0.04 raised to the time. And of course, if I actually do that math, 1 minus 0.04 is 0.96. So I get 25,500 is times 0.96 raised to the t. That's an equation that's going to tell me the population of the town after t years. So here they want us to determine the amount after 10 years. So all we're going to do is plug in 10. So 25,500, 0.96 raised to the 10th. Definitely going to need a calculator for that. And we get 16,953.23, so we're going to round that to the nearest whole number. 16,953 people is what we would estimate there to be after 10 years. And then doing the exact same thing, but this time we're going to take the 0.96 and we're going to raise it to the 25. And we get 9,190.11 people, something like that. So we round that to 9,190 people is the estimated population after 25 years. All right, those are two real quick quick examples of working with exponential functions and exponential equations. But hope you remember that, because if you have a quick understanding of that, you're going to be fine when it comes to exponential functions in AP Precalculus.